Let's say I'm the atom fluorine. Well, I have an atomic number of 9, so I'm going to have 9 protons and 9 electrons, right? So I'm going to have 2 electrons in my first shell and then 7 electrons in my second shell, my valence shell. The thing is, though, I want to have 8 electrons in my valence shell to satisfy the octet rule. I want to have a full valence shell, right? So how am I going to do that? I'm going to do that through bonds. So bonds allow atoms, essentially, to gain valence electrons or to lose valence electrons in order to reach a full valence shell. So there's 3 types of bonds that are really important for you to know. Ionic bonds, covalent bonds, and metallic bonds. So I'll first talk about ionic bonds, right? So ionic bonds occur between a nonmetal and a metal. So a nonmetal and a metal. So you're probably wondering, right? Like, what is a nonmetal? What is a metal, right? So if you see this dark line on the periodic table, I'm going to highlight it. That's going to be the line that lets you know whether an element is a nonmetal or a metal. So elements to the left of this line, they are metals. Elements to the right of this line are nonmetals. And elements that fall on this line, some of them are metalloids, which essentially means that they demonstrate characteristics of both nonmetals and metals, but we don't need to worry about them for this lesson. So an example of an ionic bond that I'll give you is NaCl. So sodium, Na, and chlorine, Cl, right? Na has an atomic number of 11, so it's going to have 11 protons and 11 electrons, and Cl has an atomic number of 17, so 17 protons and 17 electrons. So let's draw that out. So let's say this is Na's nucleus. It's going to have 3 shells and 11 electrons. So 2 in the first shell, 8 in the second shell, that's 8, and then 1 in the outermost valence shell in its third shell. Let's say this is chlorine's nucleus, right? It's going to have 3 shells as well, right? It's in a period 3, so that means it's going to have 3 shells. 2 electrons in the first shell, right? 8 in the second. And then 7 in its valence shell. Well, here's the thing, right? If I'm chlorine, I want another valence electron to fulfill the octet rule. And if I'm sodium, right, I want to lose this valence electron so I can have a full valence shell, right? That way I won't have this third shell anymore, and my second shell will be my valence shell, and I'm going to have a full valence shell. So how is that going to happen? Well, in this ionic bond, Na is going to give its electron to Cl. So this electron is going to go away, and Cl is going to gain an electron. Now both sodium and chlorine are going to be happy, right? Because they have full valence shells. They satisfy the octet rule. Now let's talk about covalent bonds. So covalent bonds occur between 2 nonmetals. So 2 nonmetals. So how do covalent bonds work, right? So a covalent bond is when the 2 atoms share electrons. So instead of an ionic bond where one atom takes an electron from another atom, in a covalent bond, the atom shares an electron. So like, let me give you the example of F2. So this is a molecule made out of 2 fluorine atoms. So let's say this is the nucleus of another fluorine atom. These are its 2 electron shells, and these are its electrons. So 7 electrons in the outermost ring. So if there were an ionic bond between these two fluorine atoms, one atom would have a full valence shell, but the other one wouldn't, right? So what they need to do is they need to share their electrons. So how's that going to work, right? So through the covalent bond, what's going to happen is they're going to share their electrons. So you see there's this electron here and there's this electron here. Those two electrons are being shared by both fluorine atoms. So now both of these fluorine atoms have a full valence shell, right? 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7, 8. Lastly, let's talk about metallic bonds. So metallic bonds, as it is in the name, it occurs between metals. So only metals. So metallic bonds work in a different way from ionic and covalent bonds. So let me use the example of iron, Fe. In a metallic bond, there is going to be a lattice of Fe atoms. So imagine these are a bunch of Fe atoms. So Fe, right? Well, if all these atoms want to have a full valence shell, well, for Fe, since it's a metal, it's smarter for it to lose valence electrons so it can reach a full valence shell. Remember, like we saw it with Na. So electrons are going to break off these atoms and flow through the lattice. So all of these atoms are going to be losing their electrons, and the electrons are going to be flowing through the lattice, right? In turn, because they've lost their electrons, these atoms are now going to become positively charged ions. And this is going to attract all the electrons. So that's what's holding the lattice together, right? It's the positively charged ions and the electrons flowing through them. This is also why metals are very conductive. It's because the electrons freely flow through the lattice.